For a long time, we thought we had the universe figured out. Not completely, obviously, but at least the direction it was going. The universe was expanding. That expansion was accelerating, and nothing was going to stop it. That idea sat at the center of modern cosmology for almost 30 years. And then, very quietly, the numbers started to disagree. So let's rewind a bit. Back in the late 1990s, astronomers discovered something shocking. The universe wasn't just expanding. It was expanding faster and faster. Something was pushing everything apart. They didn't know what it was. So they gave it a name: dark energy. Not because it's evil or mysterious on purpose, just because we can't see it, measure it directly, or touch it. But mathematically it worked. Here's the key assumption we made. We assumed dark energy was constant, always the same strength, never weakening, never growing. In physics language, that's written as a number called W. And for decades we believed W equals -1. That one number meant something huge. It meant the universe would expand forever. Galaxies would drift apart. Stars would burn out. Everything would slowly fade into darkness. A cold, endless future. That was the plan. Now fast forward to recently. A machine called the Dark Energy Spectroscopic Instrument, DESI, started doing something we'd never done before. It mapped the universe in 3 dimensions. Not thousands of galaxies. Not hundreds of thousands. Millions. And not just where they are, but where they were billions of years ago. It's like reconstructing the universe's entire driving history. Not just taking a snapshot. When physicists ran the numbers, something felt off. The expansion history didn't line up perfectly with a constant dark energy. The difference was small, subtle, but consistent. So they checked again, and again and again. Different teams, different methods, same tension. That number, probably the one that decides the universe's fate, it might not be -1. It might be slightly higher. That sounds boring. It's not. Because if W is changing, dark energy isn't a constant. It's something dynamic. Something that can weaken. Think of the universe like a car driving uphill. For years, we thought the gas pedal was glued to the floor. No matter what, the car keeps accelerating upward. But the new data suggests the foot might be lifting, not slamming the brakes, just easing off. And if that happens long enough, gravity eventually wins. If dark energy weakens over time, the expansion could slow, then stop, and in some scenarios, reverse. Instead of everything drifting apart forever, the universe could collapse back in on itself. A big crunch. Not tomorrow. Not anytime soon. But the fact that it's even back on the table? That's unsettling. Now, pause. This is where honesty matters. This is not confirmed fact yet. The evidence is strong, but not final. Scientists aren't declaring victory. They're saying, something doesn't quite fit. That's how real science works. No headlines first. Doubt first. Here's the interesting part. If dark energy isn't constant, that means our current model of physics is incomplete. And that's not bad news. That's opportunity. Every time the universe breaks our expectations, we learn something deeper about reality. This could help explain other mysteries too, like why different methods of measuring the universe's expansion don't agree. So right now we're in a strange moment. Nothing exploded. No law of physics collapsed overnight. But a foundation shifted. The universe didn't suddenly change. Our confidence did. Because this isn't just about galaxies. It's about how fragile our assumptions are. We built a story about the universe's future, based on a single number. And that number might be wrong. If you're still listening, you're probably not here for dramatic answers. You're here because watching ideas evolve in real time is more interesting than pretending we already know everything. That's what we do here. The universe may still expand forever, or it may slow down, or someday reverse. We don't know yet, but for the first time in decades, the future of everything is back in question. And honestly, that's kind of beautiful.